In this lecture, we'll be studying about the const qualifier. So we will see what is this const qualifier and what it is used for. Okay, so let's get started. So talking about the const qualifier, at times we may need to define a variable whose value we know cannot be changed. So we have already discussed about variables. So what is a variable? A variable is something that can store a value, and we saw that the value of the variable can be changed over its lifetime during the course of the program. Now, there may be times when we want to declare a variable that should never be changed. So in those cases, we are going to make use of something known as the const qualifier. Now you must have got an idea what is this const. It actually stands for constant. It is going to be a value that will remain constant and which will not be changed. So let's take an example. So there may be a variable to refer to the size of a buffer size. So we know that a buffer size may never change. So there may be a variable that specifies the size of the buffer, and that size of the buffer should never change. So instead of using a simple variable, I can make use of a const qualifier in order to make it a variable whose value will never change. So if we use a normal variable, it is easy to change the size if needed. So if you want to change the size of the variable at some point, it is better to use a normal variable. But if we want to prevent code from inadvertently giving a new value to the variable, it is better to use something that is constant, that is something that cannot be changed. So in case we want to never change that variable, we want it to remain constant, and we don't even want our code to accidentally give it a new value ever. So in those cases, it is always better to use something that is constant, and that is the const qualifier that we are going to make use of. So this const qualifier will make a variable constant and we will never be able to change it. So that's what we mean. So we can make a variable unchangeable by defining the variable's type as const. So this is how we can make a variable unchangeable. We can define it by using the type const. So we will specify const before the variable name, and that will specify that it is a constant. So this const qualifier will tell the compiler that this variable is a constant and it should never change. And if we try to change it, it will throw an error. So let's take an example here. So here I am declaring an integer variable called buff size. So let's imagine that this is the variable for storing the buffer size. And I'm initializing it to the value 256. So this is the input buffer size, and I don't want this 256 to change ever. The buff size should remain 256 throughout the program. So what do? I make use of the const qualifier here. So I put this const keyword before the int, and that tells the compiler that this buff size of the type integer is also a constant, and so it should never be changed, either manually or even by the code. Okay, so as I said, this buff size is defined as a constant, and any attempt to assign to buff size is an error. So we already initialized the value of buff size. So later, after this, if you try to assign another value to this buff size, it will throw an error. So for example, here I am trying to change the buff size to 512. So I'm saying buff size equal to 512. This is going to throw an error because we attempt to write to the const object. So the const object will be initialized and the value will be assigned during the initialization itself, and later we are not able to write anything to that const object again. So this is how the const qualifier works for making a variable constant or unchangeable. Okay, now we will discuss about initialization and const. What are the valid ways of initializing the const variables? So as we said, because we can't change the value of a const object, after we create it, it must be initialized. So we said that once the const object is created, we can never change it again. So because of that, we should always initialize the value. That means whenever you are defining a const object, you should always give the value to that const object during the time of definition itself. So that's why we say it should be initialized, and later on we are never able to change it. So because of that, we have to always initialize a const object while creating it. So let's take some examples. So here I have a variable of the type integer. It is called I, and it is declared as a constant. So it is const, and then here I am getting the size from some function called getSize. So this is a proper initialization because it is initialized at runtime. So why do I say it is initialized at runtime? Because when we run the program, at that time this function will run and we will get the size from this function, and whatever size we get from this function will be stored in this variable called I, which is an integer and also which is a constant. So this is a proper initialization even though it is initialized at runtime. Now next, here this is an example of compile time initialization. So here again I am declaring another variable called j of the type integer, and this is also a constant, and I am assigning it the value 23. So at compile time we are initializing it. So that means while declaring or defining this const variable j at the time of declaration or definition itself, we are initializing it with the value 23. So this is a valid example of compile time initialization, and this is a valid example of runtime initialization. So it does not matter whether it is initialized at compile time or runtime, but the only thing is it has to be initialized during the time it is defined itself. Okay, now here in this example, I am declaring another variable called k, which is of the type integer, and this is also defined as a constant, but I am not initializing it to any value. So this is going to throw an error. It will say that k is uninitialized constant. So as we said, a constant variable always have to be initialized. So since it is not initialized here, it is going to throw an error. So this kind of definitions are not valid. Okay, so moving on, let's take a few more examples. So here I am defining an integer called a. It's a variable called a of the type integer, and I am initializing it to the value 21. Okay, this is just a simple definition. Next, now here I am defining a variable called ci of the type integer, and I am declaring it as a constant, and I am initializing it with a. So this is also valid. The value of a is copied into ci. So what is the value of a? The value of a is 21. So 21 is copied to ci. So what will happen is that this ci will remain 21 forever. You can change the value of this a later on, but the 21 that is stored in ci from this a will not be changed again. It will remain a constant. And next, here I am saying int b equal to ci. So here what happens is that I am defining a variable named b of the type integer, and to this b I am storing the value of ci. So what is the value of ci? Ci is holding the value 21 from here because a was 21. So that same 21 will be stored in b. So here the value in ci is copied into b. So that is what happens. So these are all valid type of definitions using const keywords. Okay, now one more thing that we need to know is that whenever we define a constant object, they are local to a file. That means each constant object that you declare, they are local to a file, which means that they are available only within that file. So if you try to access a constant object from another file, so let's say that a constant object is defined in one file and you are trying to access it from another file, then it will not be possible by default, because by default const objects are local to a file. Now what if you want to access a const object from one file through another file? So sometimes we have a const variable that we want to share across multiple files, but whose initializer is not a constant expression. So at that time, what are we supposed to do? So if you want to share constant variables across multiple files, then you have to declare it using the extern keyword. So to share a constant object among multiple files, we must define the variable as extern. So we must specify this keyword extern even before the constant keyword. And that tells the compiler that this constant variable can be shared across multiple files, and hence it can be accessed from other files as well. So let's take some examples. So we will see how we can define a variable as extern so that it can be shared among multiple files. So here in this example, let's say we have a file called file_1.cc. And then here we are defining and initializing a constant that is accessible to other files. So in this file1.cc, I am declaring this variable called buff size. Now this buff size is an integer, it is a constant, and also we are declaring it as extern. So it is an extern constant variable of the type integer, and it is getting its value from some function called fcn. Okay, now what it means is that whenever we are defining and initializing a constant as an extern, then it is specifying that it is accessible to other files too. So even though it is declared in this file1.cc, it will be accessible from other files too. So let's say we have another file called file_1.h. So file1.h. So in this one, I will be able to access the same buff size. So if I say extern const int buff size, it is the same buff size that is defined in file1.cc. So why am I able to access it? Because it was declared as an extern. Since it was declared as an extern, I can access it in this file too, which is different from this file. So see the difference. This is file1.cc and this is file1.h. These are two different files. So in this file, I declared it as an extern, and because of that, in this file, I am able to access that same buff size again. So remember that whenever you want to make a variable accessible across multiple files, then we have to, number one, declare it as an extern, and also when you are accessing it, you have to access it using the extern keyword. So this extern keyword is very important. So the extern keyword enables us to share constant variables across multiple files. Okay, so that was about the constant objects being local to a file by default and how we are able to share it across multiple files using the extern keyword. Okay, so with that, I hope you have understood what is the meaning of the const qualifier and how it makes our variables constant and how they can be defined and also how they can be shared among multiple files. So I hope this lecture is clear to you. Thank you for watching and see you in the next one.